All right, let's get right into it. As a plant operator, your most important tool isn't a wrench, it's not a radio, it's the mental map of the whole facility that you carry around in your head. What we're going to do here is make that map crystal clear so you can really see how everything fits together. Because a strong foundation, well, that's the key to operating safely and effectively every single day.
So, to kick things off, let me ask you a question you probably weren't expecting. What does a plant operator have in common with a doctor? I know, it sounds like a weird comparison, but trust me, the answer really gets to the heart of what you do.
And the answer is, you both check vital signs. I want you to think about it this way. Your plant is your patient. It's got a pulse, a temperature, critical pressure points, the whole thing. Your job is to understand its anatomy, to constantly monitor its health, and to spot those little warning signs before they turn into big emergencies.
You know, any complex system, no matter how big and overwhelming it seems, can always be broken down into simpler parts. And a process plant is no different. In fact, pretty much every single piece of equipment out there can be sorted into just two fundamental families. Understanding this basic divide, that's the first step to mastering the plant's anatomy.
And here they are, static and rotating. That's it. It really is that simple. Static equipment, no moving parts. It just sits there and does its job. Rotating equipment, on the other hand, has parts that are spinning, turning, and moving all the time. And that one simple difference completely changes the game when it comes to risks and how you operate them.
So let's start with the giants that stand still, the static equipment. I like to call these the unmoving workhorses of the plant. They contain, direct, and transform everything flowing through the process, and they do it all without any internal motion.
First up, we've got vessels and drums. You can basically just think of these as the plant's containers. They're designed to hold fluids, maybe act as a buffer in the process, or just give materials time and space to separate from each other. Simple idea, but absolutely vital.
So for you, as an operator, this means you're always watching a vessel's vital signs, its pressure, its level, and its temperature. If you lose control of any of those, you're looking at two huge hazards: overpressure, which could cause a catastrophic rupture, or overfilling, which can send liquid where it's not supposed to be, causing all kinds of damage downstream.
Next up are those towering structures you see all over the plant, columns and towers. A classic example is a distillation column separating crude oil. Inside these massive vessels, you've got vapor rising and liquid falling, and that contact between them is what allows a mixture to be separated into its different parts.
Now, unlike a simple drum, a column is a whole different beast. It's a delicate balancing act. It doesn't just have one temperature or one pressure. It has an entire profile of them that changes from the top all the way to the bottom. Your job is to watch those profiles like a hawk. The big risk here is unstable operation. If you lose that balance, the whole separation process just falls apart.
Okay, let's talk about the plant's temperature control system, heat exchangers. It doesn't matter if it's a huge shell and tube exchanger or a bank of noisy air coolers, their job is always the same: transfer heat from one fluid to another, either to heat something up or cool it down.
For you, the key is watching the inlet and outlet temperatures. That tells you how well the exchanger is doing its job. If you start to see the temperature difference between the two fluids shrink over time, that's a classic sign of fouling. It's basically a gunk that builds up inside and acts like insulation, slowly killing the exchanger's efficiency.
If the plant has a heart, this is it, the reactor. This is where the real magic happens. A reactor isn't just a container. It's a special vessel designed to control a chemical reaction, transforming raw materials into valuable products.
Now, because chemical reactions create or consume massive amounts of energy, the stakes here are incredibly high. Temperature and pressure aren't just numbers on a screen, they are absolutely critical. As one safety guide puts it, loss of control can lead to serious incidents, and that's putting it mildly. This piece of equipment demands your total focus.
And finally, in our static family, we have the storage tanks. You usually see them all grouped together in what everyone calls a tank farm. Their job is pretty straightforward. They're the plant's warehouses, safely storing huge amounts of raw materials and finished products.
For a tank, the number one thing you're watching is the level. It sounds simple, I know, but overfilling a tank can cause a major spill. And that spill isn't just an environmental mess, it can create a serious fire hazard that puts the entire facility at risk. So yeah, level monitoring is critical. All right, we've covered the static giants. Now let's switch gears to our second family, the movers, shakers, and drivers. If the static equipment makes up the bones and organs of the plant, then the rotating equipment, well, that's the circulatory system and the muscles. It's the heartbeat that makes everything go.
The most common piece of rotating equipment you're going to see is the pump. Its job is simple: move liquid from point A to point B through the plant's massive network of pipes. You can really think of pumps as the heart of all liquid flow in your process.
Now, a pump needs to be fed correctly. You have to make sure it has the right suction conditions. That means enough liquid at the right pressure. And why is that so important? Because if one critical pump fails, it can starve the rest of the process and bring the entire plant to a grinding halt.
So, where pumps move liquids, compressors move gases, but they do more than just move them. They squeeze them, which increases their pressure. We're talking about a high-energy, high-speed machine that's absolutely critical for any process that deals with gases.
And all that speed and energy creates some pretty unique risks. The most dangerous one is a condition called surge. It's a violent, hammering reversal of flow inside the machine that can be totally catastrophic. For a piece of equipment like this, your own senses are one of your best tools. You're always listening and feeling for any tiny change in how it runs.
And to round out the family, we have fans, blowers, and turbines. Fans and blowers are kind of like low-power compressors. They're for moving air or other gases at lower pressures. Turbines do the exact opposite of a pump or compressor. They use the energy from a moving fluid to create power that drives other equipment.
But here's the thing. There is a golden rule for all rotating equipment, from the tiniest pump to the biggest turbine. Because they all have parts moving at high speed, they have two universal vital signs: vibration and noise. Any change in either one of those is a huge early warning sign that something's wrong. An unusual noise is often the very first clue that trouble is brewing.
So we've toured the whole plant, from the static giants to the rotating drivers. We've talked about what they do and what to watch out for, but all of this knowledge, it all points back to one single thing: your most important job, and that is being the eyes and ears of the plant.
This is how you stop failures before they even happen. It all boils down to 4 simple actions. 1. Listen for any new or strange noises. 2. Look constantly for leaks, drips, anything that seems out of place. 3. Feel for unusual heat or vibration when you're doing your rounds. And number 4, and this is the most important one, report. Trust your senses. You know what normal sounds and feels like out there. If something changes, you report it. That simple action is what keeps your patient, the plant, healthy and safe.